Well, good morning and welcome. I am going to go through lesson 11.1 with you. And for those that you don't have me as a teacher, my name is Mrs. Oppold, and I have first hour Algebra 3 this year. So let's look at section 11.1. It is all about exponents. And as you recall, we have done some work with exponents already this year. We have worked with using the properties of exponents. We've evaluated and simplified expressions. That's what we're going to achieve today. And then tomorrow, day 2, we'll work with solving equations. So this is day 1. That's what the lesson will be about today. Tomorrow, or the next time we meet, that'll be day 2. Well, let's just get started. Hopefully you have your note packet. If not, I would encourage you to print off 11.1, pause this video, go into Schoology materials page for chapter 11, and go ahead and print this off. So looking at your notes, I'm going to get mine beside me too, you will see that you have all the rules of exponents written here again. And like I said, we've done some of these before. We've got the product, the quotient, the product where we add the exponents, quotient where we subtract the exponent, the zero property, which gives us a value of 1. So like 3 to the 0, we know that that would turn out to be 1. Negative exponents move the entire expression. So if I had a negative exponent, I would move it as 1 over, it drops it to the denominator. Power rule, these two powers end up multiplying when I have a single base with a power raised to a power. Here you'll see I think of it kind of as distributive one, where I distribute that power to both the numerator and the denominator, resulting in expression that goes a to the m over b to the m. And a special rules down here, still it is a negative exponent rule. It just moves it. It moves it to the top now, and it is written as a to the n over 1, which is just a to the positive n. All right, and here you can see it shifts things. If the top has a negative exponent, it goes to the bottom. If the bottom had a negative exponent, it goes to the top. We'll see all of these getting put in place as we go through our examples. So let's get started. We've got 4 examples. We're going to do examples 1 through 5 today, so you can kind of see we're going to be basically covering the first side of the notes page today, and then tomorrow we'll hit the rest of it. When I look at these, the first thing that I notice is that I have 2 bases that are the same, which allows me to put it together as m equals 8 plus 6, which gives me m to the 14th. Final answer. On the next one, the first thing I'm always gathering is look at those bases. And right now you can kind of see that m and n are not agreeing with one another. So this cannot be simplified. The expression goes, it's a to the m, a to the n, and that allows us to go a to the m plus n. But in this case, we have different bases. So cannot simplify because bases are not the same. All right, bases are different. I would encourage you to put those little notes in your notes as well. It just helps when you're looking back at it, maybe as you're doing homework, to say, oh, why didn't I finish that one? Why didn't I call it 9th power? Well, now you'll know. So this is the answer. All right, looking at C, a couple things I see is that I have a coefficient out front. So I'm going to bring those together. The other thing I'm really loving is the fact that the bases are the same, the p's. So we will definitely be able to do some simplifying on this. I'm going to bring my -5 out front. I'm going to bring the -9 out front, p to the 4th, p to the 5th. And you're like, wait a minute, why can you rearrange those? Well, there's that little property called multiplicative commutative property, and that allows us to switch them around. All right, so -5 times -9 gives us +45. We're going to take those 2 p's and add their exponents together to give us 45p to the ninth. Problem's done. D, well, there's a lot of rearranging on D as well. So I'm going to take -3 and 7, multiply them together. I'm going to take my x's and work those together. And lastly, we're going to bring the y's together. These are the details that, a good math student finds out right away when you've got to scan your problems, right? And just see, what am I dealing with? Make a game plan. My game plan was, I'm going to put like stuff together just to help my brain a little bit. I could put parentheses around that. Sort things out. All right, next step. Well, let's do the -3 times 21, which would actually give us -21. And then the x's, I can add those exponents together. So I get a 2 plus 1. And the y's, with the bases being the same, we're going to add those exponents together. Final line, let's simplify. We get -21, x to the third, y to the seventh. All right. On to the next one. I just had a phone call, Miss Sable. So we were checking in with each other. On to example 2. This one's using the zero property of exponents. So let's just say if you look at your little box of rules up in the right-hand corner, does it have a to the 0? Yes, it does. A to the 0 equals 1. This is the rule we're going to be expanding upon right now. 29 to the 0. Easy. It's 1, isn't it? How about this one? -21, or -29 to the 0. Well, the thing I notice is the negative is enclosed in the parenthesis. That means that it is talking about the negative number, -29, which that will turn out to be 1. In C, this is a little different. The negative, I'm going to highlight this, the negative is definitely separate from the 29 to the 0. Do you see that? This is the one distinction that my kids have the hardest trouble identifying, that this will turn out to be -1. Okay? It didn't have the parentheses like example B. And then finally, D, I'm getting 8 to the 0 is 1, and 15 to the 0 is 1, and they show a subtraction between them, so I get 0 for that answer. I think sometimes the zero properties can be the most confusing ones, just because of the parentheses, non-parentheses. Working with negative exponents, this would be the rule that looks like a to the negative n equals 1 over a to the n. So that's the rule I'm using. I'm going to make this then 1 over 6 to the 5th. And 6 to the 5th is going to be a pretty large number. So I think we'll just call it good right there and not expand it. For B, notice the parentheses, right? These are the details that good mathematicians notice right away. We have parentheses. That means then that I'm going to take my exponent and apply it to both of them. So this will turn out to be 1 over, because of the negative exponent, 2 to the positive fourth, x to the positive fourth. Okay, 2 to the fourth isn't too bad. I can do that one in my head. I know 2 to the third is 8 times another 2 would be 16, x to the fourth. If you want, dig out that green power sheet if that is in the binder, because, why not have that alongside you? It makes it easier. 2 to the fourth, boom, you can look it up, you got it. For C, I don't see any parentheses. So the -4 is only applying to the P. The -7 does not get dropped below then. It's just a -7. It's a negative number. And then it would be over P to the fourth. And there's these little qualifications here where P cannot equal 0. Because if P were 0, we'd have a 0 in the denominator. So it's just ensuring that the problem is doable. I lost my headphones. Hang on here a minute. All right. D, let's evaluate this one. 4 to the -1. Well, 4 to the -1 we'll write out as 1 over 4. 2 to the -1 we'll write out as 1 over 2. And then we've got the subtraction in between it. All right, so basically the problem says I've got 1/4 minus 1/2. I gotta have like denominators in order to subtract fractions. And 1/4 minus 2/4 would give me negative 1/4. All right, moving on. Example 4. Wow, this is just going so fast. I hope you're having as much fun as I am. That kind of sounds like Mr. Rogers, doesn't it? All righty, here we go. I watched that movie last week. It was good. 1/4 to the -4th. This is the, I guess it falls under the special rules in our little box of rules where they had, whoops, they had n there, didn't they? 1/a to the negative n becomes a to the positive n. So that's the rule I'm going to make use of. I'm going to take this, swing it up into a numerator position then. So negative exponents, if it was on the bottom, it moves it to the top. If the expression was on the top, it moves it to the bottom. Not so bad. B, they both have negative exponents. Oh, wow. Okay, well, then one of them's going to move down below and one of them's going to move on top. I'm going to take the top, move it to the bottom. That's going to become a 3 to the 3rd on the bottom. And the negative expression on the bottom is going to move to the top. Now they both are written with that positive exponents. And just to finalize, 3 to the 3rd, not so bad. Look it up in your green table if you don't know it. 9/27. I rested my hands like I was done. I guess I'm not done because this would simplify, wouldn't it? It becomes 1/3. Sorry, my classroom lights just went out. Hopefully I'm not in the dark too much. Moving forward, example 5. This is our last example for today. And then tomorrow we'll pick up with example 6. All right, so for A, m to the 8th over m to the 13th. This is what we refer to as a quotient, right? We see division. And the rule for division is a to the n over a to the m. And that gives me a to the n minus m. I subtract my exponents, top minus bottom, and this becomes m to the 8th minus the 13. That would be an m to the -5. Oh, -5. Now we get to kick in the negative exponent rule and write this as a positive 1/m to the 5th. Remember in Math Excel, they do not like you to finish problems with a negative exponent. So just get in the habit of always rewriting them. It's true for all our courses that we do require students to write that as a positive exponent. All right, B. I see a couple possibilities with B. One is I could use quotient rule. And if I go, you know what, let's call this option A, because some people will see this option and some people are going to see my option B. So I've got two different ways I'm going to approach this problem. Option A, I'm going to use the quotient rule. And for that, that would say 5 to the -6 minus the bottom exponent. And we know that two negatives sitting side by side become a positive. So I get 5 -6 plus 8, which gives me 5 to the 2nd. Oh, I can do that one in my head. 25. Option B. Option B should definitely be in blue, shouldn't it? Okay, let me get option B here, in blue. Instead, on this one, I'm going to use the negative exponent rules. And that rule is going to look like moving things. So I'm going to take 5 to the -8th and make a positive 8, putting it up on top. 5 to the -6, move it to the bottom. And now I'm going to go into quotient rule, 8 minus 6. So here I'm picking up my quotient rule. And 8 minus 6 gives us 5 to the 2nd. And 5 to the 2nd is 25. What? We got the same answer? How can that be? Well, thank goodness that's the case, right? Because we should have gotten the same answer. It's the same problem. We just took two different approaches to it. And that's one of the things I truly love about math is the fact that we always get the same answer if we apply rules appropriately. C, when you see C, what do you see? Well, the first thing I see, you're probably getting sick of that. I wanted to draw some eyes. The first thing I see on this one is the fact that I have a base of x and a base of y. And because those bases are different, I'm done with this problem. I cannot simplify it further. So the answer is what we see, x to the third over x to the fifth. Kind of a nice one to finish with. Bases are not the same. I encourage you to write this, are not the same. So cannot be simplified. So cannot simplify. This would be my answer. All right, it's been fun. It's been real. It's been real fun. Um, example 6, example 7, I should be coming up. We'll do those the next day. Now, look for worksheet. It should be called worksheet 1 in your packet. It has 28 problems. That is your assignment. They will be going pretty fast, I assume. Just apply all those rules. And I'm looking, just kind of scanning through this. What I would say on this one is we've got to apply that 3 to both the top and the bottom, right? And then 17 and 18, oh wow, do they ramp up, right? 4 will apply to this. This will, maybe write this down, this will become 4 to the third, c to the fourth. Did I say 4 to the third? 3 to the fourth, c to the fourth, 2 to the fourth, y to the second raised to the fourth. And now simplify that, and then use a quotient rule. I would probably work here next and simplify that. We've got some negative exponent rules. You'll handle those with ease. 23, 24 look a little fun. I tend to be a person that moves things right away. If I see a negative exponent, I'm moving it. So that 8 to the negative second is going to drop to the bottom for me. The 8 to the negative third from the bottom is going to move to the top. I wish I would have wrote it in front, but that's good enough. And the 3 stays put. Now, the only thing left to do on that problem is to simplify those, okay? And then you're done. 24 going to be kind of the same. Move things with the negative, move things with the negative, move the negative. Ooh, watch that one. I see different exponent or different, different variables. I would move the n, and then that's about as much simplifying as can happen. All right, I'll leave you with this fun stuff to do. I hope you have a wonderful day. Bye-bye, guys.